Good morning, good afternoon, good evening. Welcome to another episode of Hands on SAP Dev with me, DJ Kumakura, and special edition, joined today with the one and only Nora and the one and only Kevin. It's going to be an amazing episode. This is all about retrieval augmented generation. I don't really know what that is, so I'm super excited to learn more from these two experts here, my colleagues, my lovely friends and colleagues. I'm going to just sit in the background here. I'm going to monitor the chat. So welcome everybody who's joined. Please put in the chat where you're from, say hello, be chatty, and ask questions. Be curious. So Nora and Kevin are going to show us some really cool stuff. So yeah, let's go. We've got our coffee. We've got our screen sharing facilities. Oh, coffee in a glass. That's a bit trendy. Oh dear. That's anyway. I've got my
Actually, it's not in the glass, but I mean, I only had weird mugs, and I was thinking glass is safer option.
Glass is safer. Okay. So yeah. So say hi in the chat, and I'm going to hand it over to you two. Off you go.
Hey folks. As DJ introduced me, my name is Kevin, and I am part of the developer advocates team. Just a quick introduction of myself, and I'm pretty much handling CAP and a little bit of consumption of AI. Like, I'm not a super deep AI expert. For that, we have Nora, but I know how to write a CAP service on top of the AI capabilities. So I'll let you quickly introduce yourself, Nora, before I dive into the topic.
Thanks. Yeah, I'm Nora. I'm also a developer advocate for AI. I'm not sure who the deep AI expert is here, but I will try to answer all the AI questions today. And yeah, I'm just really excited to see it in CAP because I always do it in Python, and I just know we have a JavaScript plugin. So I'm also curious how everything works.
Cool.
Yeah.
Okay, then I'll just start sharing my screen, and then we can just dive right in. So basically, the idea is that AI is taking over the world. We've seen that on several movies. So we want to make sure that we have some control over it and expose those AI functionalities via some sort of a service, right? Because SAP is offering AI features via SAP AI Core. It's using partner models in the background for chat completion or embedding generation, those kind of things. And we as developers, we want to have a way to expose these features to the outside world via an API or within a UI5 application or any other way, right? So we have to figure out how to do this, how to set everything up, how to implement those API calls, the features, those kind of things. And that's what we want to show you today. And I'm going to show you all the coding part and the architecture and how everything is connected. And Nora will fill in the knowledge gaps of all the beautiful AI stuff. That's basically what's going to happen today. And we're using CAP for that because CAP introduced the CAP LLM plugin. It's currently in beta, so please don't use it for production yet, but you can try it out. It's available via NPM package, and you can just simply consume it within your Node.js application. What I'm showing here right now is the CAP AI Vector Engine sample. As you see, we're also going to use the HANA Vector Engine today, and we will go into a little bit more detail later when we look at the actual architecture. But that's a brand new sample repository Nora and myself created. It did go live yesterday. It's complementary to this live stream as well as to this blog post I've created. Both links will be available in the description of this video. And we also have in the description of the video the link to the CAP LLM plugin samples repository, which has a little bit more samples in there, more extensive samples than what we're going to show today. So what is it we're going to show today? So basically, Thomas Young and Rich Heilman had a roadshow where they did CAP and ABAP through Europe, right? It was a couple of weeks back. And we thought it would be funny to actually ask an LLM model on where they will stop on a certain date or which people might join on one of those code jams. So we want to talk to the model, ask the questions, and get the response back. And for that, we're going to write a CAP service exposing that functionality. And we're going to train the model to understand our business context. And you can translate that into different business scenarios as well. This is just a fun, easy one we want to do today. But from a technology perspective, this is all going to be the same. So that is what we're going to do today. And now I've thrown in some of the buzzwords like embeddings and LLM and vector engine and those kind of things. And I think it's a good point where I hand over to Nora to explain to us the buzzword bingo I've just introduced. So we have a little bit more of an understanding of what we're actually going to do today.
Yeah, definitely.
And for that, I stop sharing and hand it over to you.
Okay, you stop sharing and I take over. 1 sec. Share my screen. Can you see my screen?
Not
Can
yet.
you? Yeah?
Not yet.
Not
I
yet?
can't see it. Nope.
Why not? Share.
Oh, it's coming now. There we go.
Okay. I just saw someone was joining from Hamburg. That's cool. I'm also in Hamburg, so hi. Just wanted to quickly put that out there.
Yes, that's Ere.
Ah, cool. Also Turkish, I'm assuming, or German Turkish or whatever. My husband is Turkish, so merhaba. Yeah, so I just quickly wanted to share some AI buzzwords that Kevin was already starting to throw around. I shared some here on the slide. If there's any that are confusing you, you can also type them in the chat. If you have others that you want explained, also type them in the chat. I will just quickly go over the most important ones for now. And that is hallucination. Hallucinations are large language models have some limitations, right? They have hallucinations, which is like a form of limitation. They have biases. And they have the problem that their knowledge is basically limited to whenever they were trained. So large language models do not continuously learn more. They are trained and then they stay in that state. And that's the problem, because if you then ask them, for example, about like, I don't know, the latest election, the large language model itself does not know. And hallucinations are a big problem, especially in businesses, because the thing is, you probably don't realize that the model is hallucinating because the model itself doesn't even know it's hallucinating. But what we mean by that is that the model returns a response that sounds grammatically correct, so you really won't know, but it's factually completely made up. One example of that, I, for example, tried yesterday, where I asked, tell me about the time traveler that showed up to Stephen Hawking's time traveler party, return the response as a JSON with keys, name, and age. And I mean, we know that no one showed up at this party, right? Because like there are no time travelers currently. But it just returned a name, John, and age 30. Very plausible. So we don't know. Maybe Stephen Hawking did hang out with John 30 during his time travelers party. And then when you ask the model, like, are you sure? Sometimes it says, oh, no, you're right. The name was actually Josh or something. Yeah, so that's a hallucination. And that's what we want to prevent here. Another problem is that large language models sometimes also say, I don't know. And the problem is that models actually, they don't know that they don't know. They were trained to say, I don't know. But that's also a problem, because if we ask a question, we want a real response, right? Now, what can we do to prevent this? DJ already mentioned it. It's called retrieval augmented generation. That is a technique to ground large language models. A lot of people talk about grounding all the time. There are different ways to ground models. What we will be doing today is implement retrieval augmented generation. And in order for me to explain that, I just quickly want to show you what embeddings in vectors are, because a lot of people don't know what that is. Here you see a vector space with 3 dimensions. Now, large language models typically use like large vectors. So for example, in the case of OpenAI, we have 1,536 dimensions. So a vector with 1,536 numbers. Now, why do we have to turn our words, sentences, books, or chapters or whatever into embeddings in the first place? Because large language models, as any other machine learning model, works with numbers. So we have to find a way to represent our human words with actual numbers for the model to understand. And we do that by putting all these words and sentences and documents into a vector space. And the the cool thing about the vector space is that these vectors hold a lot of meaning. So for example, the vector Berlin has the same relationship to the vector Germany as Washington, DC has to the US, because it's the capital. And the cool thing about vectors is you can even do like vector calculations. So for example, the vector Washington, DC, and then when you subtract the vector Berlin and add the vector Germany, you get the vector of the United States, which is really cool. And that's how you can use embeddings to, for example, implement retrieval augmented generation. And for that, I want to give you a quick example. Maybe you can, for a second, think about if you went to school or you have a child that goes to school, what do you do when you have to read a book for school? Do you buy a summary book, like I used to do in my days? Do you ask ChatGPT, or does your kid ask ChatGPT? I don't know, do you listen to an audiobook? Like, what do you do? Do you actually read the book? Because like in my time, no one read the book. Now your kid might have the really smart idea to ask ChatGPT all the questions your kid has to answer about the book, or even write the essay for your kid. The only problem is if that book was not part of the training data and your kid hasn't read the book, your kid won't realize when ChatGPT makes up a lot of things about the book. Now, chances are the teacher read the book, so the teacher will realize. What can you do to prevent all these problems for your kid? You can actually take all the books your kid has to read for school. You load them in a vector database. And then when you have the question about the book, you also turn the question into a vector. And now what we can do is with these vector calculations, we can take the vector of the question, go to our database and say, which of your entries, like which vector in here is the closest vector to mine? So which is the most relevant information that you have for my question? And then we take that text of that embedding and send it to the large language model and say, hey, large language model, here's my question. Instead of answering from your knowledge base, please answer using this context information that I just gave you. And that's what Kevin is going to do today.
Yes. And it's an actual thing. My wife is a teacher and she has to deal with that every day. Like she gets essays, they sound like a PhD thing, and those are 7th graders. So yeah.
This may be a good time to jump in with a question from Mark Teichmann. Is HANA Cloud Vector Engine also available in HDI instances? Now, I think I know what the answer to that is, but I thought I'd relay that to you both.
So yeah, we're actually gonna do that way. We have a HANA database, HANA Cloud database up and running, and I have my HDI instance, and then we operate.
Nice. I was trying to delay the question, so it would be a nice surprise and the answer sort of subtle. But, anyway, perfect, great. Thanks for asking the question, Mark, and keep your questions coming, folks.
Cool. Before we dive into the coding, let me just quickly show what we're gonna do. So let's take a look at the CAP LLM plugin. So we need a way from within the CAP application to communicate with GenAI Hub, to communicate with HANA Cloud. We have to have a way to construct all the HTTP requests to those backend services, right? We don't want to think ourselves about how they have to look like. It would be great to have like a simple API we can use. And for that, we can use the CAP LLM plugin. It's an NPM package. We can include that in our CAP application. And the CAP LLM plugin can do all sorts of things. For example, anonymization, those embeddings we've talked about, similarity searches, those are the vector searches, right? Then we have the check completion, and then reg responses. All of those we can execute. And those calls, those APIs, we can execute, go against the GenAI Hub or SAP HANA Cloud Vector Engine, depending on the configuration and depending on the API call we're going to do. And then below GenAI Hub on Business Technology Platform, we have the partnership models, AI models. We have some from AWS, from Google Cloud, from Microsoft, and so on. And for example, today we're going to use the Azure OpenAI LLMs, as far as I know. And the end-to-end architecture of what we're going to implement today, at least partially implement, looks like that. So I've drawn that out. I hope this is big enough. So the architecture is fairly easy. We have a CAP service within BTP, Cloud Foundry runtime in that case. It can also be in Kima. And we have application clients, mobile, desktop, or any other application connecting to our CAP service, consuming whatever we're exposing. And then within our CAP service, we have the CAP LLM plugin, which does all the interaction with SAP AI Core and the SAP HANA Cloud Vector Engine. For example, it connects to SAP HANA Cloud for the vector embedding and similarity searches. Or it connects through destination service. So we have to define a destination pointing to SAP AI Core. And then from there, going through the AI APIs to, for example, the Azure OpenAI services. And that's pretty much it. That's all we got to do. Before I continue, do we have any questions? I know there's a little bit of a delay in the chat, right? But
yeah, there's always a bit of a delay, but no further questions yet, but I'll relay them as.
All right.
Thanks, Kevin.
Cool. So that's what we have here. So it's pretty simple. I've already configured all of that because that would take too much time to configure that. But in the blog post, as well as in the sample repository, we have links to documentation and tutorials helping you to create a destination on BTP, to instantiate a HANA Cloud instance, and also to fire up a GenAI Hub instance for yourself, doing all those kind of things there. So it's all documented and you can follow along. So no worries about that. And from here, I wanted to hand over back to Nora because she's going to show you how the AI Core and the GenAI Hub actually looks like and how those models can be created or connected. And then after that, we go into some nice light coding.
Yeah, I'm just going to share my screen and kick you out.
Nice.
Did it work faster this time?
Yeah.
Okay.
I mean,
great. Yeah, so SAP AI Core, as Kevin already said, is our AI runtime, where you can train custom machine learning models, but it's also the base of generative AI Hub, and also like underlying for Joule and all kinds of AI embedded scenarios that we have. And there are different ways you can access AI Core. One of them is, for example, using the Python SDK. One is the AI Launchpad, which you see here on the screen. One is via a Swagger user interface, and also, for example, with the VS Code toolkit, which is also really cool. But we will show you the SAP AI Launchpad today, because that's just if you start with this topic, it's the easiest to understand it. Now, what you see here is that you can connect your AI connections. I connected AI Core, but you can, for example, also connect the AI services here and then do things with those services. But we want to have a look at Generative AI Hub. So I connected my AI Core instance. It's a service on BTP, so I get my service key from here, right? I think you've all seen BTP. So I created an AI Core instance and a subscription to AI Launchpad, and then I just connected it here. Here you have your resource groups. I'm going to use default, but you can, usually I create a resource group for every project so that they don't mix. Yeah, and then over here, what we see is Generative AI Hub. We will look at that in a second, but first what I want to show you is the machine learning operations, because when you want to use a large language model through Generative AI Hub, you first have to create a deployment for yourself so that you get a URL that you can use to access the model and a deployment ID. And for that, we have the scenarios. Let me quickly explain what you see here. So when you want to train a model yourself on SAP AI Core, you will have to create a scenario. And then with that scenario, you can create a configuration. You need the configuration to tell AI Core like which input data set to use and what the output should be like and so on, where to find the data. So that's what we need the scenario and the configuration for. And then we create a training execution and the output will be a model and the model can be deployed. Now with large language models, it's a little bit different because obviously the model is already trained by one of our partners or by SAP, depending on the model that you want to use. So let's have a look at what we have here. The scenarios that you see here are scenarios that I created. The only scenario that SAP is providing out of the box is the foundation model scenario. One quick fact about the name foundation models. A lot of people ask me why it's sometimes called foundation models and sometimes called large language models. The thing is that we had language models, right? And then when OpenAI came out with ChatGPT or the GPT models, they were called large language models because they're like gigantic language models with lots of data points in the model. So really, really big models. And then Stanford University actually introduced the term foundation models because they realized large language models can do a lot more than just produce language. They can also summarize text. They can also do simple math. They can write code. They can do all kinds of things. So the term foundation models kind of fit better. And foundation models nowadays is even a little bit broader than that. It doesn't have to be for languages only. It can be for images. It can be for code generation. It can be for all kinds of things. And that's why we call them foundation models. And in here, we see what models are available. So we have the open source models that we deploy, that SAP deploys for you. Here you can see we have the Mistral model and the Falcon model right now. Then we have the Azure OpenAI models, which we will be using today. And what you see here is that we have the GPT 3.5 Turbo model, the GPT-4 model, and also the text embedding model. And that's important to know because, for example, SAP HANA Vector Engine or any vector database, they actually don't do the embeddings themselves. But what they do is they store embeddings that you create with an embedding model. And what's also important to know is that you cannot exchange these embedding models for different large language models. So if you, for example, want to query GPT-4 or GPT 3.5, you always need to use the Azure OpenAI model because the embeddings have to fit the model. Now, if you would, for example, want to use a Google model, which we also have available here, then you would have to use the text embeddings from Google. Okay. I want to deploy a model and show you how that works.
Perfect. In fact, before you or while you're deploying the model,
Yes.
there's a question from Somnath asking basically about availability of SAP AI Core in BTP trial. They said they know it's available at the moment on the free tier. Do we know, you, me, Kevin, collectively, whether there are plans to make this available for trial?
No, it's only in free tier, and the plans are also not to make it available for trial right now.
Okay, well, that's a nice straight answer. Sorry, Somnath, but if you can get hold of an account that we can use free tier, then that'll be great.
Yeah.
By the way, Ramza Kuchenbecker, I hope I pronounced that correctly, says, is it possible to leverage LLMs without generative AI Hub?
Yeah, I mean, not with SAP, although technically whenever you can query, like whenever you can do like a standard REST call, you can query models from anywhere, right? But
Exactly.
if you want to have like all the role management and all kinds of things that SAP offers on top, then you have to use it through Generative AI Hub. That's the only way at SAP to actually use a large language model directly. Indirectly, you use large language models to SAP a lot. For example, the document information extraction service has a large language model in the back. Joule obviously has large language models running in the back.
Sure. Yeah, that makes a lot of sense. And I think that's the same with lots of different facilities that SAP offer. Yes, you can use them directly, but, SAP provide a wrapper, an abstract layer around them, which, has lots of advantages, has some disadvantages, but generally, there's a good reason for that sort of abstract layer.
Yeah, and
Fantastic.
one thing that I think is cool about Generative AI Hub is that, let me actually show you that right now, maybe before we deploy models, so that's clear. If we, for example, go to the prompt editor here, where you can basically just query models, you can swap out all the models that you have deployed. Now, I only have deployed these models right now. Yeah, Vitaly actually deployed another model. That's why we have two 3.5 models here. Hi, Vitaly. But every model that I have deployed, I will see here. And that's the cool thing, because you can just type one prompt and then compare all the outputs of the different models without having needing like access to all the different model providers. I just have access to Generative AI Hub, and I can use all the models that we provide, which I think is cool.
Perfect. And while we're still talking, we've got a question from a longtime friend of the Hands on SAP Dev show, AP, I think from Dusseldorf, if I'm not mistaken, where to get this model dependency information. Maybe we need a little bit more information, AP, from you as to what that means. Also, to a question, Michael asked a question, Michael C. Let me know in the chat, Michael, what you mean by evolution for the SAP CAP LLM plugin, and then we can maybe better answer the question. Cool. And Ramza Kuchenbecker says, thanks for the extensive answer. Right. Back over to you, Nora.
Okay. I'm just going to create a configuration of the Falcon model. Falcon conf. So we need to create the configuration to then get the deployment URL, right? So we will use the scenario foundation models that SAP provides version, and we want to use an open source one. Now I have you guys on my screen here. Next. It's already the Falcon model I want to use with the latest version. And then I will create this configuration. And with the configuration, I can then create a deployment. And once I have the deployment, that's the URL that I can use to query my model. And I'm the only person, that can use it. I will give the information to Kevin, so he will also be able to use it. No one else can interfere with my calls there or anything. Now, it takes some time for the status here to turn into running, and then you will have a URL appear here that you can use with this deployment ID. But since we will not use a Falcon model anyway, but one of these models, 3.5 today, you will be seeing this deployment ID in Kevin's code in a bit, and this is the URL that you could use to query it. Now, let me quickly show you what you can do in, this is just the normal chat editor of Generative AI Hub, but I just want to show you one hallucination maybe just to showcase. So first we will ask like this. Where is Thomas Young? Which date are we using? The 19th of April or something?
19th, yeah.
19th? Okay. During his roadshow on the 19th of April. Okay, it's probably going to say, I don't know. Sorry, but I cannot provide real-time information or updates on specific individuals. Now, the thing is, when we tried this the first time, it actually just gave us a random answer. I think it said like New York or Japan or whatever. And the thing is, OpenAI and other large language model providers, they continuously try to improve the results, right? And how does that work? Now, a large language model by default cannot have a conversation. It doesn't know to answer questions. What it does is it actually just completes text. So if you would ask a completion model, like a base large language model, a question, what the model would do is just produce more questions that are similar to your question. Because models in the beginning, like before you train them to be a chat model, they just complete whatever you started. Now, what OpenAI and other large language model providers did was to actually use supervised and reinforcement learning techniques to actually retrain a model to understand how a conversation works and how to answer question actually works. So they would give the model question-answer pairs and say like, this is the question, this is the answer, do that. And then once the model started doing that, they would put people there and have the people grade the responses, like good response, bad response, good answer, bad answer. And that's how GPT and other models started to actually have a conversation like we know it today. And that's also why these responses change all the time. And this time, for example, when they retrained the model, they taught the model to not give answers on things that it probably doesn't know. But again, the model does not know it doesn't know. The model just learned the most probable response to such a question is I don't know. If that was clear enough. It's very confusing. But we can do something to trick the model and give us a response anyway. So let's just do that. So if I now ask, where was Thomas Young on April 19th during his roadshow, return the response in JSON format with keys, city, and date. It will probably come up with a random JSON. So he was not in New York City, we know that. The date is correct though, because I asked for the 19th of April. That's a hallucination. We know that because we know where he really was. But I mean, for anyone else, that might as well be true. Yeah. And with that, I think, do we need to know anything else before you start, Kevin? Did I forget anything?
No. I think we got everything.
Cool. Yeah, then can you show us how it works in CAP?
I can try. All right. Get rid of this. So, okay. So basically, I've said we have the destination configured, which points to the URL Nora provided to me. And we have a running SAP HANA Cloud instance with vector engine up and running as well. So the only thing we got to do is implement this little part, our service. And that we will do now, because I'm going to show you the calls up here. We want to go into our database table and see some text chunks. We want to see the embeddings. We want to actually get the embeddings from the LLM to store them. And then in the end, we want to execute a RAG response. And I think nobody can actually see what I'm showing you in the URL field, but doesn't matter. So that's what we're gonna want to that's what we want to do. So let's open up Visual Studio Code, and I have a CAP application, as you know, with an app folder, DB folder, server folder. And then we have a package.json with all the dependencies we need. And as you can see, we have the CAP LLM plugin defined here. And then we've been talking about a lot of configurations for the connections to the AI Hub and what kind of deployment we want to use, what API version we want to use, and so on. So basically, that is what we've configured here. You can see generative AI Hub we want to use for the jet model. We want to use the AI Core Azure OpenAI destination. This is the deployment URL Nora provided me. Then we want to use that API version. And then for the embedding model, to create the embeddings, we want to use, the AI Core Azure OpenAI destination with that deployment URL here. So those are pointing to different models. And then down here, we have our BTP destination, which points to the generative AI Hub. So the connection can be established by the CAP LLM model plugin. Then we have two services. One is the roadshow service, and that defines two functions. One is the get rec response, and one is execute similarity search. And then we have the embedding storage, and that's just basically defining, like we can call the document chunk table to get the chunked texts back. And then we also have a store embeddings and a delete embeddings we can call. That's basically what we have in the service definition. And then if we go into the implementation, I've done a little bit of preparation here because that's quite a lot of code we have to implement. So I'm just going to show you the main ones. But basically we say we want to have a text loader, and this text loader is coming from the LangChain NPM package. And then we have a recursive character text splitter, also from the LangChain package, we're going to use to do the chunking for us. And then we have our store embeddings function, and we're going to implement that. So first, we want to implement the chunking itself. And that we can pretty much do just by calling or instantiating the text loader. And I'm just going to show you that one line of code where we actually, let me do it different. I'm lazy. I just don't want to code all of that. I don't want to bore you by just coding all of that. So I'm just going to copy and paste that in here, and I'll walk you through it. That also will give us a little bit more time to answer questions if needed. So what are we going to do here? First, we connect to the CAP LLM plugin. Then we say, okay, give me the entities from the document chunk table. Then we have an array text chunk entries. That's where we write all the text chunks in. Then we instantiate the text loader from the LangChain package. And we basically just give it a path to our input file. And the input file is a simple text file. And that is going to be used to create the embeddings. That is the context we give to the model, Nora explained before. So the model understands or will understand our questions. So let's take a look here. This is the text file, and this is just an excerpt of the blog post written by Rich Hyman about the roadshow. It has all the information in there about the schedule, where they will be at what date. and a little bit more information. So you can see we have just some text here, and then here, this is the interesting part, is here are all the dates with the cities where they will be. And then down here we have additional information about the single locations, and one, you got to remember that for later, Antonio will join them in SAP España. And we will ask the model later not only about where they will be on the 19th of April, the answer will be Paris, but we'll also ask them for who will join them in Madrid, Spain. So we'll see if the model will actually give us the right response for that. So going back into the implementation here, we load that text file, save it into our document, and then we call the recursive character text splitter, and then we define a chunk size, chunk overlap, and a start and the start index if we want to use that. And honestly, I've just played around with those values. I guess people who are really sufficient with AI can fine-tune that a little bit better, but I played around with that. It just basically defines how big the chunks of that text splitting should be. So the chunking means how does the text chunk function chunked all of that text into little pieces. And I don't know if you want to add something to that, Nora, or if I explained everything we have to know from a implementation standpoint to make that happen.
Yeah, just maybe a quick small fact there. The chunk size is not going to be 500 exactly. It's just like roughly 500. But it will use an algorithm to actually like do the chunks in a smarter way. So it's not going to just cut out in the middle of a sentence and then just lose all the context. It's going to see like paragraphs, length of paragraphs and stuff. It's going to actually be a little bit smarter about the chunking. There are different chunking algorithms or like also tokenizing algorithms. And this is going to, I think the chunk size is going to be maybe a little bit bigger. And the overlap is important if you really, really do not want to lose any information. But for our example, this works perfectly fine.
Mm-hmm.
Yeah,
just one thing, Kevin, sorry to interrupt. So ME or me is asking about the plugin, the CAP LLM plugin. Now, this might be my misunderstanding, ME. If it is, or me, it's my fault, sorry. The question is the plugin available on other runtimes? Now, I would interpret that as basically the plugin is not runtime specific. The plugin is a CAP plugin, and CAP itself is independent of runtime. So you could run it on Cloud Foundry, on Kubernetes, or whatever, right? Is that right, Kevin?
Correct. Yeah, it's just a basic JavaScript NPM package we can just include here, and it's provided by the CAP team.
Great stuff. And by the way,
a question. Oh, sorry. The recommendation on chunk size, it really depends on the use case. I hate that answer, but with machine learning, it's almost always the answer. It depends on the use case. It depends on the fact if you're like, I don't know, how much information is in your text, it's like really dense information, then you could have like smaller chunks. Do you want to basically check the entire documentation about something? Then you might need bigger chunks. Then you can also say, for example, to the large language model, do not only use the most relevant chunk, but use the 10 most relevant chunks that you can return from the database. And again, especially with large language models, a lot of that right now is still to try out whatever works for your use case, because large language models came so fast, and there's so much we still figure out. Also, like prompt engineering, for example, how you write the prompt. It's still not like a science. It's not even really a science, but people are trying to make it a science, So try out whatever works for you, and it kind of depends on the use case.
Yep. And one more thing before we let Kevin put his fingers on the keyboard again. Sheku is desperate to find out about being able to connect to GenAI Hub from the ABAP world. Now, I think the answer is that's coming, but I don't think we have that quite available yet.
No, the only thing you could always do is you can just use the deployment URL with the bearer token, and then you can just query that from anywhere with a standard REST.
Exactly. Thank you. Thanks for all your questions, by the way. Keep them coming. Right, over to you, Kevin.
Yeah. So we use the text loader from the LangChain package to load the input text file. We use the recursive character text splitter with the chunk size 500 and the chunk overlap 0 to create the text chunks. And now we want to make sure that those text chunks get fed to the embeddings model to create the embeddings we need for later to feed it to the chat model to give us the right answer. So we want to implement that as well. So we say here, we iterate over the text chunks, and then we use our vector plugin. This is the CAP LLM plugin, and call an API get embedding, and then we just throw in the chunk, and it will establish a connection to the embeddings model and feed the text chunks to the embeddings model, and then it will return back the embeddings. And each embedding we get back, we feed into one of those entry objects. So this entry object has like 3 properties. One is the text chunk, so we put the text chunk in, the metadata column, which is just a file path, and then the embedding. And a little helper method up here, which is the array2 vector buffer, and we're not going to go into detail about that, but we're using that to basically transform that embedding into like a vector format, so we can store it into vector engine of the HANA Cloud. And then we say text chunk entries push entries, so we feed those entries into our text chunk entries array. And now we want to save all of that beautiful stuff into the SAP HANA Cloud Vector Engine database. So let's do that. Oop. Sometimes my hand overworks and sometimes it doesn't. Okay. So what we do is we just basically say, as you know it from other CAP applications and probably stuff DJ already showed you in previous live streams, we just say insert into document chunk. This is our table. And then we just say, write those entries in there. And then we check the insert status. If there's an error, we throw an error. As you see, it's like super professional error handling here. And if there is no error, we basically just say embedding stored successfully to the database. That is all we have to do. So every time someone calls store embeddings, we load the vector plugin, the CAP LLM plugin, we read the input text file, we split it into chunks, we feed those chunks to the embedding model using the CAP LLM plugin, get the embeddings back, and write that into our HANA Cloud database. So that's what we have here. And then down here I have a delete embeddings, which just basically does a drop table. And that is just cool for going back and forth between the model and see how your embeddings work. Because in the beginning, when I implemented that, I never got the right answer back, because sometimes the chunks were too large or too small. Sometimes the question I've asked, the prompt engineering part was not right. So I had to delete those embeddings every now and then and just refeed them depending on the chunk size and so on. So this is just a little helper method on my side to make my life a little bit easier. Then the next part now would be to implement our get-rec response. And for that, again, we have just created this CAP implementation here. And then in here, we can use the CAP LLM plugin to call the get-rec response function. And that is fairly easy. I'm going to copy that as well, just because we don't have enough time for me to type it all out. So again, we just connect to the CAP LLM plugin, and then we say vector plugin get rec response. And it expects a couple of parameters here. One is the query from the user, in that case, in which city are Thomas Young and Rich Hyman on April 19th, 2024. And that, of course, could be a chat window you've implemented. Actually, the CAP LLM plugin samples repository has a use case where there is an actual UI where you can type stuff in. But in that case, we hard-coded that. Then it expects the table name. In that case, this is the SAP Advocates demo document chunk. It expects the embedding column, so where the embeddings are stored in. And for us, it's just called embedding. And then the content column. This is where the text chunks are in. And for us, this is called the text chunk. And then it just returns the response. And that is super cool because we were talking about, oh, why do I have to use SAP for this? Why cannot just implement it myself? I mean, you can implement it in Python, you can implement it in JavaScript, you can implement it in any other language you want, but you have to create the HTTP request yourself, you have to handle the connection yourself, all those kind of things. Here with the CAP LLM plugin, it does everything for us. We have the configuration on where it has to go with the request. And we have the get_rec response, which creates and constructs the HTTP request for us with just those parameters we feed in there. So it's a little bit easier than doing that all by myself. And then down here, if you're interested, I have also the similarity search, which will return a lot of vectors to me, which I can do like vector calculations on. And I just wanted to show you that it's as simple as the one above. We basically feed it the table name, embedding column, content column, and the embeddings, and then the algorithm it should use for calculating the vectors. But enough talk, let's try this out. I have to first make sure that I'm logged in. I should have done that before, but whatever. So I'm log into the Cloud Foundry CLI. And before this, like before we have the live stream, I've made sure that my CAP application locally is bound to the HANA Cloud instance as well as to the destination service, so we can do something cool. We can use CDH watch to try everything out locally with a true and real connection to the HANA Cloud instance and with a true and real connection to SAP AI Core. And I really like that one because I can use the real backend systems and the real database persistence, but can locally change stuff. And that is where I can change the query, for example. I can play around with the query, I can change the wording, I can change the questions and see what the real response from the LLM actually is, which I really liked. Because I don't have to deploy it all the time, I can just go in and do it. So let's go back here and let's call the document chunk. Let's see if there is something in there in the table, and we see nope, there is nothing in our database table yet. So let's make sure to get something in there. So we call our store embeddings function we've just implemented, and you can see it takes a little bit of time. And down here, we can actually look into the console and see what it does. And that is, I think, super cool. So first, it creates that post request, and you see it's going to the deployments with that ID, embeddings, API version. So that is everything we've configured in here, right? So it's establishing the connection to those deployed models, and it feeds the text chunks into the header here. It has the metadata column, it gives all the embeddings in there, and then it saves that into the database. And then up here, we can also see that it goes to the AI Core Azure OpenAI destination. It uses the destination defined here to go to the SAP AI Core. So it's really cool. We can see everything we need to see in the terminal. So if we go back to the browser, we can see, oh, embedding stored successfully to the database. And if we call the document chunk now, there should be stuff in there. You can see, we have the text chunks in here. So let's go to the database explorer of my HANA Cloud instance. And while this is loading, does it go fast? Yeah, we can look into my HDI container and look into the tables. And we can see the text chunk, metadata column, the embeddings. And I'm always a little bit, because I'm not a HANA Cloud Database Explorer expert. So
is it the open data one on the right?
I'm looking for the open data one on the right.
All the way on the right? Yes, down?
Oh, Oh, there it is. Yeah, it was behind the Zoom window. Okay, there it is. So as you can see, those are text chunks, and then here are the embeddings. So they're all in the database now. And with that, we can call, where is it? There it is. We can call our get rec response function. And if we go back here and just take a quick look in here, we can see we're going to ask in which city are Thomas Young and Rich Hyman on April 19th. And we should get back the right response. And the right response would be in Paris. So let's see. Okay, it's executing the request. We go back in here, check the terminal, and it does what we want to do. It's creating a post request with the against that endpoint, against that model. And in here, it creates the payload. So we have one which is called a role system. It has all the content here. Those are the text chunks and the embeddings. So the context of our business scenario. And then down here, we have the role user with the content in which city are Thomas Young and Rich Hyman on April 19th. So we give the model everything it needs to know to answer the question correctly. And if we pre-print that now, we see up here, on April 19th, 2024, Thomas Young and Rich Hyman will be in Paris, France for the SAP CodeGen event focused on ABAP Cloud and RESTful application programming models. So yay, we got the right answer back. Down here, we see additional contents with scorings, and we see that those answers are not really correct. So what it does is it creates all the answers and it creates scorings on those answers, how correct they might be. And as you can see, up here we get the one which is correct, and then the lower the score, the more incorrect it gets, I guess. But Nora, one question from my side. I've just stated that there is the role system and the role user. I mean, from the context, what I'm reading here, I can understand, okay,
Yeah.
system, this is like all the information that we're sending, all the context we're sending to the model. And then user, this is basically the query. Are there any more roles, and what do those roles actually mean?
Yeah, basically the roles, they're actually important if you, for example, want to implement like an actual chatbot. Because what a lot of people think is that when you start, for example, talking to ChatGPT, and then you know how ChatGPT actually remembers what you said in the past. So people kind of have this, like, I don't know how they imagine it, but some people tell me like, so how does ChatGPT know what I'm talking about? Like, is it retraining on my data, whatever I say or something? And it's not actually that when you start talking to ChatGPT, that somewhere in the OpenAI space, there's like this little model that's only for you and that remembers everything about you. That's actually not what happens at all. What happens is that you use these roles to actually, every single time you send a new prompt to the large language model or you ask a new question, it's going to send the chat history with you. So, and it's going to use the roles to do that. So it will use the role user for everything that you have typed and the role assistant for everything that the model actually has said. And that's how it's going to send back the entire chat history. And that's how it remembers what you said before. It doesn't use it to retrain or anything. It's just in that current prompt, it's going to send the chat history. And that's why also when you, for example, ask a certain question during a chat conversation, it answers it differently than if you would ask that question as the first question in the chat, because it will relies on all the past information that you gave it in that chat history. Now, when you refresh that chat, all that history is gone and you start again, obviously, and the model actually does not retrain on you or remember that. And the system role is actually funny because there you can just give like context information, but you could also do like funny things. For example, always return your response speaking like a pirate, or stuff like that. Actually try it out, it's really funny. And one more thing on chunking I wanted to add. When you talked about the chunks, I realized I didn't say that. Technically, the bigger the chunk, the better, like it depends on how big your input window is in your large language model. And that's also what you see at the end of the name of a model. These like 32,000 tokens or whatever, that's how big the input size can be, like the prompting window. And that's why basically the bigger the chunk, the better. But you have to see that the bigger your prompt gets, the more expensive the prompt will be because it's based on tokens. Yeah.
Cool. Thanks. So what I've done here, and that's the last part, is I've changed the query now. because I can do that. CDS watch, I change something in the code, save it, it restarts the service, and I can just try it out right there. So we're asking who's joining the event in Madrid, Spain now. And because you said we can do funny things with that, give instructions to the request, to the model, I can do that here as well. I haven't done that before. So this is the last parameter here. I can give instructions to that. So let's just try it and see what happens if we say return to response speaking like a pirate. Maybe it does something funny. I've never tried that before. So this is really something we haven't practiced. All right. So we changed the query. We want to ask who's going to be in Spain. And then we wanted to speak like a pirate. So let's see what happens. Execute that again.
While we wait for it, funny thing is, I just yesterday received a comment under one of my videos to speak slower. And the thing is, I just can't. Like, my sister tells me that when she listens to voice messages, whenever she listens to anyone else, she turns the speed up to 1.5. And she says, for me, she can't do it because then she can't understand what I'm saying. So I'm sorry, I'm trying. I'm really trying to speak slower. It's just impossible somehow. My husband learned German a couple of years ago, and he says, like, when you understand me in German, you understand everyone in German. Oh, and one more thing I want to say to this. Oh no, all good. Yeah.
You're good? But, okay. Yeah. So we got a response back, and he speaks like a pirate, and he gives us the right response because in Madrid, Spain, Antonio is joining. And it says, "Arr, matey." So it's actually changing it. So it would be funny to create embeddings to let the model speak like DJ, maybe. Ooh. I don't know if that's possible, but yeah. So yeah, that's pretty much it. And as you can see, it's not that hard, even for me. Like, I'm not an AI expert. Before I've written that example together with Nora, I mean, she just gave me the information she gave to you today, and that's all I know about AI. But using the CAP LLM plugin and CAP itself and BTP, it was fairly easy to create something like that. And I think that's pretty cool. And you can play around with that using the CAP capabilities and try it out yourself if you have, of course, an SAP AI Core instance. And all the code you need to get started is in that sample repository. And everything I've explained today is pretty much explained again in that blog post.
Can I just add one more thing? Here, stop for a second on the screen. So what you see here is actually not the other responses that are not correct. It's the other information that could be relevant that the model chose not to use because it's the wrong information from the database.
Well, there you go. I've learned something.
Okay, I'm done.
We're pretty close to the end of the hour. I don't know, DJ, if we have a little bit more time for questions if they come in, or if you want to see something, or if we should play around a little bit more. I mean,
well, there's a couple of questions that may not require screen share. So why don't you stop sharing for a second, Kevin, so people can see your two lovely faces and my ugly face. And so we had a question from me again, ME. Can we somehow control costs of LLMs usage or monitor token consumption? Now that's, I think, quite an important question, but I'm not sure what the answer might be.
Well, the only thing that you can kind of do to influence that is keep your prompts short, basically. The shorter the prompt, the cheaper. And also it depends on which model you're using. For example, the GPT 3.5 model is cheaper than GPT-4, obviously. Also, the open source models that we deploy are cheaper than using OpenAI and Google. I'm not sure the difference between like Google and OpenAI right now. I honestly don't know which one is cheaper there, but you can just check in SAP Help. We have like how you can calculate the usage with the AI units, which is like our pricing thing. But technically, the shorter, the better.
Great answer. We're coming to the end of the hour. We've got to stop it on a hard stop at the top of the hour. So thank you so much for all your questions, Shashank. You have a great question about similarity search response times and everything, but I think that's a little bit difficult to answer in the space of 30 seconds. to go. Maybe if we have another session, or if Kevin or Nora want to come on again and share some more amazing stuff, that'll be amazing. Stop saying amazing, DJ. So it just goes for me to say thanks everybody in the chat for being so great, asking questions, making comments and everything. Brilliant, you make the live streams. And thank you most of all, though, to Nora and Kevin. Bye from me.
Thank you so much.
Thank you. Bye-bye.
Bye. Thanks.